Hello and welcome to this episode of the Classics. Today we'll be looking at number 13, the constant d'Euler in French, so the Euler constant. So we define a sequence to be equal to u of n to be this, so the sum of 1 over k minus ln. We want to show that this converges. We note gamma its limit. We want to find an equivalent when n goes to plus infinity of this, so un, but without the ln of n, and find the nature of the sum of the 1 over k divided by the sum of k. And then the sum of the sum here, and here the sum of the 1 over k divided by n. And obviously n equals 0 is not defined because here there is a 1 divided by n, and here there are two divisions by n, so we can't define it. So let's take a look at number 13, where is it? 13. Okay, so I call a of n the sequence to be so that we have u of n to be equal to the sum of an. So for u1, for a1, it's equal to u1, so it's 1. And for n superior or equal to 2, an is equal to un minus un minus 1. So basically we split that up. Yeah, and so we get this. We expand it, so we get this. And then we use the property of the natural logarithm. So we get this, n minus 1 divided by n, and that equals to this. So we have this expression. We do développement limité in French, and it's expansion in English. But I have the habit sometimes to say limited development because I'm French. So we get our 1 of n that is here, minus 1 over n, plus 1 over 2 n squared, plus O of n squared, and the 1 over n simplifies, so we get 1 over n squared plus O of n squared. So n squared an converges to 1/2. An is strictly positive, so we can compare it to a Riemann series, and so it converges because the power alpha here is 2 and is superior to 1, and therefore it converges. We call gamma its limit since it converges. So un is equal to gamma plus O1. So we have our sum of the 1 over k that equals to ln of n plus gamma plus O of 1. The equivalent of this is ln of n because of this. So Vn is equal to, as we've said earlier, the sum of the 1 over k divided by the sum of k. So its equivalent is 2 ln over n squared, because the equivalent of the sum of the 1 over n is ln of n, and the sum of the k is n squared on 2, but since it's on the denominator, we get finally this result. So now we want to take a look at n to the power 3 halves times Vn. So it's equivalent to this, so I just replaced, but I took the equivalent, I replaced. So by L'Hospital rule, we can derivate. So I derivate 2 ln by n, and I derivate square root of n divided by n. So therefore we get 4 divided by square root of n, and when n goes to plus infinity, this goes to 0, so therefore this converges to 0, and so this has 0 as its limit as well. So we also know that Vn is positive, as sum of positive divided by positive. and it converges by comparison to a Riemann series. And W of n is equivalent to ln over n. So after a certain rank, Wn is superior to 1 over n, and so it diverges by comparison to a Riemann series. So the part, well, the part that will matter is the divided by n in this, and since the series of 1 over n diverges, so this cannot converge. So that's it for this exercise. Feel free to ask a question if you have one. I'd be glad to answer them. And thanks for watching, and bye.